Yeah, good day, everyone. Thank you for joining Okunola Academy. Thank you for subscribing to our channel. Please do subscribe to this video as well. Today, we are going to be looking at a topic that says what really is a unit truth test in a quantitative research or in a quantitative analysis. Now, the aim here today is to demystify the concept of unit truth test. It is done in most quantitative analysis or time series data. Now, having said that, this is the outline that we're going to be following today. However, this video here, sorry, this picture here, it's an offshoot of the past video. You may want to take a look for clearer understanding. In that video, we examined the steps that are used in performing regression analysis and the decision tree. That the decision tree that is taking the steps of what you have to do before your estimation proper. So going into what we have today, we're going to be looking at what is unit truth test. Then thereafter we examine why or the need why we perform a unit truth test in a quantitative data or research. We'll examine the basic assumptions as well of unit truth test, and of course the common unit truth test that is often used in literature. Now, having said that, now we'll look at what is unit truth test. However, before we dive in, it is necessary that we understand the concept that necessitates the need for the unit truth test. Looking at this data set, we can say that this data set runs all through from 2010 to 2024, and these are different data sets. Now, it is assumed that data sets are gathered at different point in time. Data, all of this data we're seeing, they're gathered at different point in time. And when that happens, we say, excuse me there, um, when that happens, we said there are a series of scenarios, series of events, or series of circumstances that could alter or fluctuate the process of gathering these data. Now, when this happens, we say that this data will exhibit different the data gathering processes because of that event. Now, if that happens, we said that this data exhibit what we call the random walk behavior. The random walk behavior. Now, for example, some of the things that could impact the data gathering process of this data is the fact that price could become um, a determining factor, whether in affecting it positively or negatively, and price could go up or down, or perhaps it could be technological innovation in an economic activities which could also impact or influence the process of data gathering. And when these data exhibit the random walk, what we simply say is that the effect of past behavior, the past process of gathering this data, or the effect rather of shock that necessitate the process is permanent. Is permanent on the data such that it varies. It brings about variance in the data that is gathered. And again, the data's average, as the case may be, or the mean, becomes not constant. They are not constant over time because of these events, because of these scenarios, because of these fluctuations in the economy. So having said that, we assume that once you gather this data, you assume that you have gathered data, raw data that exhibit some of these characteristics, some of these features of fluctuations and all that in his gathering process. So therefore, to subject this data into reasonable estimation, to subject this data into process of applicability and prediction purposes, then we have to ensure that we perform a unit truth test in this data to make sure that it becomes stationary. By so doing, we mean that the stationarity of the data tend to return to a mean, return back to a mean over time. So that's what would necessitate the need for a unit truth test. So in that wise, what is a unit truth test? Now, a unit truth test is a statistical procedure that is used to ascertain if a data set is or are stationary. Now, to test whether this data set becomes stationary, whether in the long term they return back to their original uh, um, original mean, as it were. Now, as often said in most literature, it is unitary tests that give rise to stationarity result. It is the unitary test that give rise to stationarity result, and not the other way around. The unitary test is performed to ascertain the stationarity outcome of a given data set. Likewise, unitary test serves as a tool that is used to check whether the statistical properties, the properties inherent in this data, the mean, the variance, autocorrelation, whether they do not change over time. Whether they do not change over time. That is only when you can now subject it to further estimation. But recall, this is not so with the behavioral randomness of the way this data is collected. So in that wise, we say when data is or are collected over time, then we perform the unit root test. Now, if you look at this is a yearly data. Unit root tests can also be performed on a daily, weekly, or monthly data set. Now, having said that, this graphical illustration could make the analogy above more clear. Now, if you look at these two graphs, this is a stationarity pattern, and why this is a random walk pattern. Now, look at this is that once this series bounces up and down, they find their way back to the vertical line one way or the other. In that wise, you make it stationary. That's the pattern that irrespective of how the data is generated, then once you perform your stationarity, then you should have a way that pull the data back to a level whereby you can use it for further estimation. Whereas if you look at random walk, you see that it's pretty difficult for this series to even find itself back to this trend line. So they wander far away or drift away from a fixed point. They drift away from a fixed point of this. The reason why once you have data like this, then you need to subject it to estimation. So why do we perform unit truth test? Why do we perform unit truth test? As said earlier, you need to perform that to validate your result. And in validating your result, you are validating your process, the process of your model. So now once you validate um, the model, then this would avoid you leading, avoid the result leading to a spurious uh, outcome. Spurious being the fact that the outcome, when unit truth test is not performed, could lead to a situation where you cannot take or make informed decision based on the outcome. You cannot use it for forecast, and which also lead to us saying that you perform unitary tests for accurate forecast. Recall that I said because of the characteristics and features inherent in raw data that need uh, that need to be subjected or to unitary test, then it then means that once that is done, you can use the data set for prediction purposes. So here we say stationary variables can be used for prediction. You can use it to predict, while non-stationary variable requires that further steps are taken in order to bring those data back to a position whereby they can be used for estimation processes. And one of that is to difference the data, or perhaps you can transform the data. Further video will be uh, done on this to further um, show the practical outcome of what is being said here. Then again, you perform unitary tests to make sure that you can make inference, you can make decision, you can infer, from the specified hypothesis, and of course you can validate it as well as have the confidence interval of what has been estimated as it were. So the basic assumption is that data are time series model. Once data are time series model, that means you can data that is collected on a daily, weekly, monthly, or yearly basis. Then it follows a process. The process is called the auto-regressive process. Auto-regressive in the sense that it auto is self, estimate itself using the statistical process. That's the literal meaning. When you say auto-regressive, we mean that a process where models predict future values. You predict future values, just as I've said earlier, in a sequence that is based on your past event or past value. You predict future based on past value. So in that way, this data recall from what the data shown earlier, that these has to be followed. So again, we said one of the basic assumption is that as a result of this auto regressive process, we have to test the presence of that in the data set to check if it actually follows this process. And again, we assume that residuals are normally distributed and have constant variance. We assume they are normally distributed and have constant variance. But in the real sense, from the raw data, do they have these properties? Do they have these characteristics? Do they demonstrate these characteristics? It is only when they are subjected to the unitary test then we can now take our positions. Then again, we said it assumed that time trend deterministic components are properly specified. It has no autocorrelation in the error term, and that the lags are appropriately specified. These are the basic assumptions that lead to carrying out the um, unit truth test. And the common unit truth tests, as it were, are commonly used actually. We have the ADF test, we have the PP test, we have the KPSS test, and of course we have the ZA 0100 test. Now, for ADF, Philipppiron, and KPP may follow the same um, estimation pattern and decision criteria pattern. For instance, the null hypothesis is often said that the series or the data set has a unitary test, and the alternative is that it does not, and this is based on the decision criteria of the p-value of the probability value rather of 0.05, whether to reject or to accept. So either way, once it is less than 0.05, it means that the null hypothesis that says series has a unit root, yeah, means that not it is not it is not accepted. So you have to do the next estimation process, which is to difference it and decide whether it has become stationary or not. Now, of all the unitary test that's mentioned, the ZA is works inverse of the other one that I just specified. For example, if you look at ZA is based, his decision criteria is based on steps, is based on certain steps that must be taken, unlike the previous ones that I just explained. For example, in ZA unit truth, what you have to do now is you have to choose or specify your level of significance, and after that you have to compare your outcome. You compare your output after performing that based on the probability that's been specified using the Zevor test critical value table. So this is the only difference between this other unit root test, and I hope you would have understood this reason why unit root test is used in quantitative research. Thank you. Please do not forget to hit the like buttons, subscribe to this channel, and please share. Thank you. Bye.